Okay, for chapter 6, right, I'm going to move rather fluidly between 6.1 and 6.2. Okay, so 6.1 is the binomial expansion of 1 plus b to the power of n, and 6.2 is on the binomial expansion of a plus b to the power of n. Okay, so 1 plus b to the power of n is actually a special case of a plus b to the power of n. Right, so I will move rather fluidly in the entire chapter. But we will start with the basics first, okay, and understand the notation n factorial. Okay, this is an exclamation mark, you never say wrongly, but this is called n, read as n factorial. You don't come and tell me n exclamation mark, or you come and shout n at me very loudly. Yeah, you don't say, you know the n, okay, no, right? It's called n factorial, right? So what does this actually mean? N factorial is a value itself, which is n times n minus 1 times n minus 2, going down the multiplication to 1 itself. So for example, if I talk about 7 factorial, it will mean 7 times 6 times 5 times 4 all the way till it is times 1. Okay? There is a calculator button that you can press for such values. Alright, so if you were to take a look at your calculator, if you are using the Casio one, at the top right hand corner below the on button, there is one that is an x factorial. That is for the Casio calculator. Okay, for short calculator, does anyone have it? Can you find it yourself? Can you find? Look for the one that has the factorial sign. Can you find it? Okay, you need to know how to press the calculator for it. So let's just do a check. 7 factorial, try. What do you get for the value?
5040.
Yeah, you should get 5040. Okay? So we will not expect you to go and, if I ask you to find the value of like 12 factorial, I don't expect you to do 12 times 11 times 10 times 9. That will take forever. Okay, just press the factorial symbol. Okay, unless of course the question says without the use of calculator, which is what we see in try 1. Okay, they say without calculator, evaluate 11 factorial over 8 factorial. Of course, in the exam, they will not ask a question like that, but we need to learn how to actually simplify, and we start it by using numbers. Since 11 factorial, right, it's actually 11 times 10 times 9 times 8 times 7 all the way to times 1. And 8 factorial is 8 times 7 times all the way to times 1. What we can see here is that technically I have an 8 factorial included in my 11 factorial, and I can cancel that. So eventually I have a 11 times 10 times 9, and that is 990. Okay? Simplify n factorial over n plus 1 factorial. So now got no numbers, then how? Okay, as I mentioned earlier, with the bigger number, which is n plus 1 being bigger, inside it will include the n factorial. So I can understand my n plus 1 factorial as a n plus 1 times n factorial. Do you agree? Okay. Then we can cancel away the n factorial. So we are left with 1 over n plus 1. The reason why we are discussing about the factorial sign is because it is part of the definition for this number here. Okay, this is n choose r. We read it as n choose r. Okay, brackets n and r. Later on we will talk more about it. But the definition of n choose r, okay, is that make sure you don't write fraction sign in between now. Okay, so it means n factorial over r factorial times n minus r factorial. Okay? Then n factorial over r factorial times n minus r factorial, we can simplify it. Alright? Okay, using our skill over here. Okay, so of course I'm not asking you to count down from n, then after that, what is before n? It's not n times m, then p. Wait now, how to go backwards? A, B, C, F, G, H, I, J, K, L, M, N, H, I, J, K, L, yeah. So it's not n times m times L, and so on and go on. You understand? It's not in alphabetical order. Okay, so we don't know where the r is inside the n factorial. That's what I'm trying to say. But we know that n factorial, I can have times n minus 1 times n minus 2. There's somewhere, okay, there will be n minus r factorial. Okay, as in the n minus r, then times n minus r minus 1, and so on, then until times 1. Okay, so what we see here is that this is the n minus r factorial. Okay, so I can cancel it out with my n minus r factorial. Therefore, it actually simplifies to this. Okay, oh sorry, what am I writing? Simplifies it to times n minus r plus 1, because right before n minus r will be n minus r plus 1. Okay? You don't quite have to worry about memorizing this. This will be provided in the formula list, in the sense that this section here will be provided and its simplified form will be provided. Okay? Right? I'm just telling you now, okay, you can just write it down. As we go through into in-depth understanding of binomial theorem, you will understand how it is going to be applied. Okay, so in part A for try 2, we want to evaluate 9 choose 4. Alright, so 9 choose 4, using the definition of this 9 choose 4, it will be 9 factorial over 4 factorial, okay, times 9 minus 4 factorial. Okay, which is actually 9 factorial over 4 factorial times 5 factorial. Okay, then we agreed that 5 factorial appears inside 9 factorial. Alright, so we can cancel out the 5 factorial and we are left with 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1, which results in 126. So that is what we could do if we need to bring out, okay, all these nitrous 4 and expand it according to the formula here, okay. But typically during the exam, if you're asked to know what is the value of nitrous 4, we press our calculator for it, okay. So to press calculator, okay, for a thing like nitrous 4, okay, we will look for this button, okay, in your calculator. It may not be a button on its own, it may be a second function, so you might have to press shift. In the Casio calculator, you have to press shift and above the divide sign. Okay, so this is above the divide sign. So could you all try using your calculator, press 9, okay, then press that button, okay, then after that 4. So if you press that, you will have 9C4 and we have 126 as our answer as well. Are we able to get that? Anybody don't know how to press? Very important to know how to press up. Okay. Okay. Then moving on from here. Okay, so if you need to communicate with me in terms of binomial, somehow if you got a question regarding binomial, in your text message itself, you may use the NCR. Okay, so if you tell me, if you, instead of writing 9 choose 4 like that, you write N9C4, I will also understand that it is equivalent. Okay? Alright, then after that in part B, we want to show that 15 choose 3 is equals to 15 times 14 times 13 over 3 factorial. So we do it by the definition. Something from the left hand side, it is 15 factorial over 3 factorial times 15 minus 3 factorial. Okay, so 15 factorial is actually 15 times 14 times 13 times 12 factorial. We can cancel out the 12 factorial. Which leaves us with what we want to show. Then after that, in try 3, it is given that n is more than 5. We want to find the positive integer value of n, such that n choose 5 is equals to n choose 3. Right, I want you to take note that generally, okay, when we do this choosing thing, okay, this combinatorics, okay, this concept is in the concept of combinatorics. Okay, so you will learn it further when you go higher level of mathematics into computation and combinations. Okay, so it's commonly used in statistics in probability. Right, so n usually will have to be a bigger number than the r value, okay? Because if in combinations itself, it's about choosing. So it's a group of people, I want to choose something, okay? So 9 choose 4 means 9 people will choose 4 people, okay? Look at the combination of these 4 people. So that's actually where the concept comes from. So therefore, it cannot be a case whereby you only got 3 people and you want to choose 4 people. Doesn't make sense, right? Okay? You cannot choose 4 people out of just 3 people. Correct? Okay, so therefore, the n value will always be bigger than the r value in order for this thing to be defined. Okay? So going back to this, right, in order to find the value of n, because we have n choose 5 equals to n choose 3, using the definition n factorial over 5 factorial times n minus 5 factorial equals to n factorial over 3 factorial times n minus 3 factorial. We simplify it. Okay, and we can cancel n factorial on both sides. So such that we get this, and then cross multiply, you get this. You can press into your calculator what is the value of 3 factorial. That would give you 6. And 5 factorial will give you 120. Okay, can you tell me between n minus 3 and n minus 5, which number is actually bigger? Is n minus 3 bigger or n minus 5 bigger? N minus 3 is bigger, right? So actually in n minus 3 factorial, we have the n minus 5 factorial inside it. So we could cancel away the n minus 5 factorial. And we are left to solving a quadratic equation essentially. So it is n squared minus 4n minus 3n plus 12 equals to 120 divided by 6. Yep. N factorial, I divide it on both sides of the equation. Yeah, divide it over omega. Okay. Right, then after that we have n squared minus 7n plus 12 minus 20 minus 8. So n plus 8, sorry, n minus 8, n plus 1. So n is equals to 8 or n is equals to negative 1. We obviously reject the negative answer since the question says it's a positive integer. Okay, so therefore answer is n equals to 8. Okay, so since you're on the topic of binomial expansion, why is it called binomial expansion? The reason is because we are looking at expanding things that has two terms inside. side that are different. A and B are distinctively different, okay? And then if I have 1 plus x, and I want to expand, let's say, square, or even 3 over here, okay? It is two different terms, that's why it's called binomial, right? We know a polynomial is multiple terms, right? Okay, therefore binomial by being 2, okay, so therefore that's why it's called binomial expansion, right? We definitely already know how to expand things like 1 plus x squared, okay, and we can also expand things like 1 plus x to the power of 3, which is a bit tedious because I need to do 1 plus x squared first, then I multiply with 1 plus x by using the rainbow method or the distributive law, okay. But then what if I have 1 plus b to the power of 10 or 12, okay, and all that? Then it is going to be very, very tedious to do it manually like that, okay? But let's just observe some patterns going on first. So if I have the power n to be written over here, if it is power of 0, 1, 2, 3, let's say we go up to 4, maybe, okay? If it is to the power of 0 for 1 plus b to the power of 0, surely anything to the power of 0 will be 1. Okay? Binomial coefficient means that it is the number in front of the terms. Okay, so the coefficient is only 1 because we only got that coefficient, a constant term. Right? If the power is n, the power n is 1, okay, then it will just be 1 plus b. And the coefficient will be 1 and 1. Okay? If it is 1 plus b to the power of 2, we know that the identity will be 1 plus 2b plus b squared. Okay, so it's actually the coefficient 1, 2, and 1. Agree? Okay, we can do it in a tedious manner, alright, to expand, continue to do the expansion to up to 3. I'm not going to make you do it. Okay, so the expansion itself, if you have the time, will be 1 plus 3b plus 3b squared plus 1b cubed. Sorry, plus b cubed. So we get 1, 3, 3, 1. Okay. And then you go up to 4. I get 1 plus 4b plus 6b squared plus 4b cubed plus b to the power of 4. So the coefficients is, let me use a different color, 1, 4, 6, 4, 1. Okay? What I'm trying to do here is to introduce to you this pattern of numbers called the Pascal's triangle. Okay, so you see that in my binomial coefficient writing, I'm opening it up like a triangle where my numbers at the extreme ends are always 1s, and the numbers in between, okay, is a result of the two numbers at the top left and right corner. So 1 plus 1 gives me 2, 1 plus 2 gives me 3, 1 plus 2 plus 1 gives me 3. Okay, so that's this actually pattern. It's a very beautiful pattern. Okay, and it's called the Pascal's triangle. Right. So if I know the Pascal's triangle, I know very well how the fifth one is going to look like. So if I use this triangle and the understanding, the fifth, the power of 5 expansion will be 1, 5, 10, 10, 5, 1. Okay, sorry, squeezing the 1 here. So power of 5 is actually 1 plus 5b plus 10b squared plus 10b cubed plus 5b to the power of 4, then plus 1b to the power of 5. You see that the terms are actually increasing powers of b. Okay, starting from b to the power of 0 all the way to b to the power of 5. Right? But of course, using the Pascal's triangle is not a realistic way of doing expansion, because you must start all the way from the top, then go all the way to the bottom. So if I were to ask you to expand 1 plus b to the power of 100, then you're going to write 100 lines of this triangle to see the pattern, then tell me the answer. That will be ridiculous, because end up the question is only 1 mark question. then how. Okay? So I will tell you how the next lesson because our time is up. Alright? So I've introduced to you Pascal's triangle ring. Okay? So the